Alrighty, so it doesn't look like we got too many people in class today, and that's totally fine. I did tell you guys that I wouldn't see you again until Friday, and then I realized tomorrow is going to be Good Friday. So I figured I'd go on ahead and give you the video that in class that we were going to do then today. So what you guys have already worked on is a project, or not a project, but an assignment that had to do with thermal energy. And you've had two of them essentially. One was on the states of matter, but then the other one was on the states of matter and what happens when you adjust the temperature, the amount of heat that a substance holds. And you got to watch the molecules move around and wiggle faster as you heated them up until they changed phases, maybe from a solid to a liquid or a liquid to a gas, or backwards. Maybe you cooled it down. So thermal energy is what we're kind of focused on right now. And thermal energy to you is just heat or temperature. But what temperature is measuring is the average amount of energy in a substance. And it's the average amount of kinetic energy in a substance. So you may have heard of kinetic energy back in 5th grade. Kinetic energy is the energy that something has if it's moving. So if I take this rock right here and I throw it up in the air just like that, as it's moving through the air, it has a certain amount of energy, because if it hits you, it's going to cause you to move as well, right? So if I get hit in the face, it's going to move my face, and there's energy there. So what temperature is the average amount of movement inside of something. I've told you guys before that your table is vibrating. It's just doing it in a manner that you can't actually feel the vibration. But the faster it vibrates, the faster the little molecules vibrate, like you see in the little GIF I have playing here. The faster they vibrate, the hotter the substance is. And you can see, if you look at this particular diagram here, the one on the left, that's at 5 degrees Celsius, they're wiggling. And if you look at the little lines in between them, those are the bonds between each molecule. And those bonds are holding on just fine. But then as you heat it up and you get all the way to the one on the right, where it's at 40 degrees Celsius, those bonds are being really stressed, and it's really hard for them to hold on. And if you heat it up enough, eventually they'll be wiggling so fast that that thing will lose its connections. The bonds will no longer hold on, and they'll let go. And that's when it becomes a liquid. So when, again, back to what we're measuring temperature. It's about the average amount of energy in a substance, the amount of kinetic energy, the amount of vibration that substance has. So we have 3 different scales for that. Kelvin, which is 0 degrees Kelvin, is absolute zero. That means there's no wiggling of any atom or any molecule whatsoever. All of them are absolutely just completely still. That doesn't exist in the universe. So there's nowhere in the universe where it's exactly 0 degrees Kelvin. There's always going to be 1 or 2 molecules moving around and vibrating. So everything has some temperature. So 0 degrees Kelvin is just a hypothetical state. Celsius is based on the boiling point and freezing point of water. So water freezes at 0 degrees and it boils at 100 degrees. And then when you look at Fahrenheit, well, Fahrenheit's weird. I don't remember the story behind the Fahrenheit scale that we use, but at 32 degrees Fahrenheit, water freezes instead of 0 for Celsius, and then water boils at 212 degrees Fahrenheit instead of 100. So it's a different way of, it's a different label essentially, but they all measure the same thing. So I don't want you to think Celsius and Fahrenheit and Kelvin are measuring different things. They're all measuring temperature. It's just a different scale. Okay, so then to the assignment that you just got done with. You were looking at this little simulation here, and you were adding heat or taking it away. And right now you see those water molecules in a solid state. And you know it's a solid state because all of these are moving together. So if the one at the very top moves, the two that it's connected to move with it. So that's how you know that right now it's in a solid state. You also know this is water and it freezes at 0 degrees Celsius. So obviously being at negative 123 or 127 degrees, that's definitely a solid state. Now, what makes a solid a solid? Well, you guys know you experientially, but a lot of you have never had to put that into words. Basically, it means that whatever it is, it holds its shape. So if I try and pour a bunch of rocks into a container, they don't suddenly change into different shapes to take up the container. They stay the same shape that they are. And I can break this rock into pieces, but all the little molecules are still stuck in the same position, even if I break them into pieces. So a solid is something that doesn't change its shape very easily. You really got to bang on it and bend it and things like that. So metals are still solid, but you can kind of bang them into different shapes. But the point is they hold their shape. They don't, if you pour them into something, they don't fill that thing. The thing to think about these solids, so what you're seeing there on the screen is all of these are bonded together, like they're grabbing onto hands and they're not wanting to let go of each other. And you can still see there's vibration there. So the molecules are still wiggling around a little bit and vibrating. The same thing's happening to your table or your iPad or the chair or bed that you're sitting on right now. The molecules in there are sitting there and they're bound together and they're just wiggling like this. Now, if you start heating them up, it gets to a point where the wiggles get so strong that they can't hold on to each other, and then it becomes a liquid. So with liquids, you lose the bond. They can't hold on to each other. I have the example on the screen of trying to grab a hold of a greased up pig. But imagine just you and your brother or sister pouring some oil on your hands and then trying to grab each other's hands. You're going to slip right off. And that's what's happening in a liquid state. All of those molecules are vibrating so quick, they can't hold on to each other and they just slide right by one another. And what makes a liquid is a liquid will fill a container. It'll form to the shape of the container. And if you keep adding the liquid up, it will take up the entire shape of the container. So you know this, like for instance, my Diet Dr. Pepper right here. It's a liquid and it's filled up and taken this particular shape. And if I pour it inside of this can, it will take the shape of the can. So it doesn't really matter what you put it in. The other thing to mention, water is liquid between 0 degrees and 100 degrees. As soon as you hit 0, it freezes. As soon as you hit 100, it turns into water vapor or gas. So anywho, that's that. Now, moving on to the gas state. Gas states, and it doesn't come off as well in the Zoom, but a lot of these molecules, water molecules on the screen in this little image, are just spinning around furiously. When you're in a gaseous state, you have a ton of energy and you are just bouncing off of everything all over the place. And that's what you see in this little video that I have, or this little GIF here, is these things aren't even trying to grab onto each other. They're moving so fast at one another with such energy that they simply bounce off of each other. And that's what gases do. If you put them in a closed container, like say a spray paint can, if you put a little bit in there, that little bit will fill the entire container. It'll just be really spaced out. They just sit there and bounce off the walls of the container continuously so that they take up the whole space. You can keep putting more in there and putting more in there, and there'll be more and more molecules, but no matter what, they'll still fill the entire container. So that's how you know it's a gas and not a liquid. Liquids will only fill up as, from the bottom up. But gases, as soon as you put them in a container, they fill the entire thing. So there's some interesting things that you are going to learn about on the next assignment that have to do exactly with that. So again, a repeat, water does boil at 100 degrees Celsius. All right, so moving on. So what we're talking about when something melts or when something evaporates or boils or freezes, Those are called phase changes. And in science, there's a lot of interesting things that come from this. Different things melt or evaporate at different temperatures. So, for instance, if I want to make alcohol from, say, corn sugar, I would have to make up a batch of corn sugar and water and yeast. The yeast would make my alcohol, but I got to get the alcohol out of the water. How do I do that? Well, alcohol boils at a lower temperature than water does. So if I heat it up to alcohol's boiling point, but not water's, all the alcohol will evaporate off and I can collect that while the water stays behind. There's all sorts of interesting things in science that have to do with phase changes. So, and we're actually, not you, but I will be doing some videos and recording some of this. I'm actually going to make alcohol and I'm going to light it on fire and launch a water bottle rocket with the alcohol that I create. I was gonna do this with you guys as a project, but unfortunately now we're all at home. So I'm going to do this to show you guys. So anyways, different things have different melting points. Example, water melts from ice at 0 degrees, just above 0 degrees, but glass doesn't start melting until 1400 degrees. So everything will eventually melt and turn into a gas if you get it hot enough, even gold, even iron. So that's something to take into consideration. Okay, now that's the quick presentation to talk about some of the things that you're supposed to be learning about. And what you'll be doing after you're done with the thermal energy assignment. So the thermal energy assignment here, what you should have found for water was it goes to from a solid to a liquid just above 0 degrees. For the temperature, it goes from a liquid to a gas, that's at 100 degrees Celsius. And then how do the molecules behave as they heat up? Well, you should have seen them starting to move around more frantically, should have been vibrating and spinning much more, moving around in a much more energetic fashion as you added heat. So you should have something like that written down. How much space do the molecules take up as you add more energy? Well, they take up more and more space. So think about it. When I have a solid, it's stuck in that one position, and I can put it in my glass here, and it will just take up that one amount of space. If I heat it up into a liquid, it'll melt. But then if I heat it up into a gas, it fills the entire container, right? So the more you add heat or energy to a substance, the more space it takes up. That's why things get less dense. If you think about the lava lamp that I have on my desk at work, when it's heated up, when the things get closer to the light, they heat up, they get bigger, right? They expand and they rise. And then as they get colder, they contract and then they sink. And that's what's happening in a lava lamp. So you add energy to a system or to a substance, and it will take up more space. And then why do you think that molecules change states as you add thermal energy? And it comes down to the fact that they're just vibrating so hard. There's so much energy there, they can't bond with one another, right? Those bonds break. So if you said something along those lines, that would have worked. So that's a review for the thermal energy assignment. Now, what you guys are going to be doing Monday, and you can get started on this now if you want. This is a little bit bigger of an assignment, is thermal energy and molecular structure. So remember, don't get sidelined by molecular structure. I'm talking about the shape of molecules. Okay, so that's all I'm talking about for molecular structure. Don't freak out. With this assignment, what you're going to do is review the states of matter before you start on this down here. And what I'm having you do is doing this whole assignment on paper. You can just take a picture of it and then add it in here. So what you're going to do for number 1 is go through solids, liquids, and gases, and you're going to draw what they look like on the molecular level. Hint, hint, if you go back to the simulation that you already did, it shows you the molecular structure of what these things look like as a solid. So you notice everything's stuck together. That's what I want you to draw, right? So show me what these things look like when they're in a solid state, when they're in a liquid state and a gas state. And I want you to give me a description so I understand what you're drawing, right? So describe the fact that, oh, all of the molecules are stuck in the same shape because they're bonded together, even though they're vibrating or whatever. So that's what I'm talking about. For number 2, this is fairly simple. I want you to look up the boiling point and the melting point for these things. So water, the melting point is at just above 0 degrees, and the boiling point's 100 degrees. So that's what you would write down. And then alcohol is a different one: copper, glass, gold, steel. So I want you to look those up. Just kind of get familiar with them. Just see the ranges is really what I want you to see, because those are fairly common things that you encounter. And then the next one, number 3, has to do with the same simulation. However, instead of clicking on the states of matter, when you go here, I want you to click on phase changes, and you're going to experiment with this. And I have a few questions for you to answer that have to deal with this. Now, you can do neon or any of these, I don't care. But the things you can change in this are obviously the heat and or the temperature by adding heat or taking it away. You can also now change the pressure, so you can add more stuff in here, and you can see as you increase temperature, things are going to change. If you look, hint, hint, at the temperature, something happens if I keep the amount of space the same, but I add more stuff in. So play with that. The other thing to play with is the finger here. As you make less and less space, things happen. Watch what happens to the pressure and the temperature when you do this, okay? So I'm having you do this to kind of understand some things, some variables with phase change. If you add more pressure and take away some of the temperature by cooling it down, you might see something happen that you don't expect. So play with this. Play with this a lot until you start to see some patterns of things happening, and the patterns that you find are what you're recording down here in the answers. And then number 4 is a very simple one. These 2 equations you've already written down and had to find before. I'm adding one more equation for you to write down. These 3 have to do with the chemistry stuff and the thermal energy stuff that we will start to do in the coming weeks. I've got some video labs to show you, some things you might be able to do at home yourself, depending on what you have in your kitchen and, you know, at the grace of your parents. So this is the assignment for Monday. Try and have it done by Tuesday. I will go over the answers on this on Tuesday with you guys. The next time I will see you will be Tuesday for class. However, if you have any questions, I will be available at 7:30 every morning from 7:30 to 8:10 for the Ask Me Anything. So if you have questions, you're stuck on something, you're not sure, show up to those. Those are essentially my office hours. I'll answer any question that you have. Other than that, that's really all I have for this particular class today. Are there any questions that you have right now?
This isn't a question about this lesson, but it's a question about April 7th assignment.
Yeah.
Where do we turn that one in at?
Okay, so April 7th, this one right here is the thing. So April 7th, you just turn it in right here. So quarantine week 1, states of matter, you just turn it in here. If you've got it as a different attachment, just hit add attachment.
Okay.
Are you having issues hitting the turn in button here, or did you just like click on it and do it and then not? Did you not click on this before? Did you take it out of the week ahead?
Yeah, I took it out of the week ahead.
Okay, that's fine. Yeah, just go to states of matter and that's where you turn it in.
Okay.
Got any other questions for me, bud?
None right now.
Okay, is this making sense?
Yes.
Perfect. All right, dude. Well, have a good weekend, and I'll see you next week.